In this section, we're going to go over something called correlations. And this is important because in other fields like in biology and chemistry, even in politics, people want to know if there is some sort of relationship between two variables. And that's what correlation is identifying to see if there's any relationship between two variables. So to begin, I want us to remind us what is an ordered pairs. So an ordered pair is a pair of number x and y written in the form xy. These ordered pair can be graphed in an xy plane. So for example, let's graph this ordered pair -1 and 1. So here we'll put this 1, -1, -1, and 1. So -1, 1 will be -1 on the x-axis and then 1 on the y-axis. So here we have the ordered pair -1 and 1. And this is important because when we want to see if there's any relationship between two variables, what people will do is they actually plot each individual ordered pair of their data set. And this is something called a scatter plot. And that's what we're going to do next. So scatter plot. Suppose you collect a data and have two variables x and y. A scatter plot is a graph in which data pairs x, y are plotted as individual points. So for example, a real estate agent wants to study the relationship between the size of houses and its selling price. The table below presents the size in square feet and the selling price in thousands of dollars for a sample of houses in suburban Denver neighborhood. Here, we want to construct a scatter plot of our data set. So you see on the left side, we have our data set. We have the sizes of the house in square feet and its corresponding selling price. So we have 1, 2, 3, 4, 5, 6, 7, 8 pairs. So we expect to have 8 points in our scatter plot. So this is playing the role of our x, and this is playing the role of our y. Great. So let's create our scatter plot. So here we want to number our x-axis. So it'll be, let's make this 2400, and then 2500, 2600, 2700, 28, 29. Okay, and notice that I didn't skip a lot. I didn't jump rapidly. I didn't go to like 2400 all the way to 2900 and all the way to 3200. There's a pattern, so I'm just increasing everything by 100. So for the y-axis, let's go by 400, then 440, 460, 480, oops, no, I'm missing something. So this is 420, 440, 460, 480, 500. Great. And remember, the x here is our size in square feet. So this is the size of houses. And then our y is our selling price in thousands. So here you could say selling price. Great. Now we could plot each individual pair. So here we want to plot x as 2,521 and y 400. So that'll be somewhere around here. And next, we do the rest for all of them. So I just jumped ahead and marked all the points that we needed just to save some time. But all I did is just I plotted each individual point. So for example, this will be 2,735 and this should be 428, which is right here. So I just plotted each point. So notice that if we look at our scatter plot, we have like a positive relationship here. So if we increase the size of the house, then we notice that sell price also increases. So this is the relationship that we're trying to look for. And that's what we're going to talk about next. Is like trying to see what kind of relationship we have looking at our scatter plot. So let's go over some definition. So here, if the points on the scatter plot seems close to a straight line, then there exists a linear relationship between the two variables. So if you look back here, it seems like there is a straight line. So we could say that this is a linear relationship. But we could go even more. We could go further than this. If two variables have a positive association, if large values of one variable are associated with large values of the other, and two variables have a negative association, if large values of one variable are associated with small values of the other. So here, notice that if I draw a straight line here, it seems like we have a linear relationship. But not only that, since it looks like it's increasing because we have a increasing x value and increasing y values, we could also say it has a positive association. So we could say that this is a positive linear relationship. Positive because it's going up, and linear because it's really close, like a straight line. So let's do a couple more examples here. So here we want to determine whether we have a positive linear, a negative linear, a weak linear, a positive nonlinear, or positive or negative nonlinear. So here, if you look closely, this looks like it's increasing and looks like it's kind of forming a line. So we could say from the graph that we have a positive linear relationship for this graph here. How about here? So notice that it's going downwards. So that kind of gives you an idea like, oh, this is like a negative association or a negative relationship. But also the data set or the data points are kind of clustered into a straight line. So we could say, that this is a negative linear relationship. How about this one? Well, notice that it's not going up or it's not going down. It's kind of staying in the same place. But we still have, it's still kind of like, it's going like this way. It's going horizontal. So for this case, we actually say there's just a weak linear relationship. Because the reason why we say weak and linear is because there's no sign of either a negative or positive association, but it still kind of clusters around a line. How about this one? Well, notice that it does increase because it's going upwards, but does this look like it's clustering around a line? Not really, because it looks like it's bending, kind of like this. So that kind of gives you an idea like this is not a linear relationship, but it's still increasing. So we could say that we have a positive nonlinear. Again, positive because it's increasing, but nonlinear because it's not clustering into like a line. Kind of looks like a logistic graph. How about this one? Well, we notice that it's going downwards, So there is some sort of negative association, but the point, it kind of clusters into a non-linear line. So it doesn't cluster into a line. So we could say that this has a negative non-linear. And again, negative because it's going downwards, and non-linear because it's not clustering like a line, like a straight line. It's a different shape. So this is great, but graphs could be misleading, and people wanted to know if there's a way to get a single number that could measure how correlated their two variables are. And there actually is. There's something called the correlation coefficient, and that's what we're going to talk about next. So here, correlation measures the relationship between two variables, and a bit of a disclaimer here, correlation does not imply causation. If two variables are correlated, this does not imply that one variable caused the other. For example, let's say you took a data set of people who were attacked by sharks and people who bought ice cream at that beach. And you notice that there's a positive correlation or positive association with it. That doesn't necessarily mean that if people buy more ice cream, people will get attacked by shark more often. That doesn't, so this kind of gives you an example that correlation, just because two things are correlated, does not imply that one caused the other. So a lot of people make that mistakes. Okay, so let's talk about the correlation coefficient, the number that we want to, or the value that we want to get. So here we can find a number that describes the correlation between two variables. This number is called the correlation coefficient, and we denote it by the letter R. So R just means the correlation coefficient. So how do we get this value? Given an ordered pair XY in our data set, with the sample mean X bar and Y bar, so we took the sample mean of all our X value and the sample mean of all of our Y values, and then we took the sample standard deviation as X and XY. So this just means the sample standard deviation of our X value, and this just means the sample standard deviation of our Y value. And then we take our sample size N, so we could compute the correlation coefficient R by this formula here, 1 over N minus 1 times the summation of all this. And this seems like a very complicated formula. So that's why people use technology to actually compute this. So for this class, I'm going to show you how we could get this value using Excel. And it's actually a lot easier in Excel. So before we do that, we want to interpret what does this value mean? What does our correlation coefficient actually mean? This correlation coefficient is always between -1 and 1. So it can't go over 1, and it can go below -1. So it's always between these two values. So if R, our correlation coefficient R, is a positive number, the two variables have a positive linear association. If R is negative, then the two variable has a negative linear association. If the value is equal to 1, this means that there is a perfect positive relationship between the two variables. And if the value is -1, means that there is a perfect negative correlation between these two variables. Oops, forgot to put variables here. Let me just write this real quick. Okay. And then if R is close to 0, then we could say that we have a weak linear association. So there's no positive or negative. It's just a very weak linear association. Okay, so let's revisit the example that we did. So we had this data set where we have the sizes of houses in square feet and its selling point, and we already did the scatter plot. But here we want to compute the correlation coefficient, our R. What is our R here? And again, this tells us how correlated these two variables are. So we have to use Excel for this. Hello, so I open up an Excel sheet and notice that I already inputted our data values. So here on the x-axis, we have the sizes of a house in square feet. And then here we have its corresponding selling price of the houses in thousands of dollars. And I just want to remind you guys that since you're a Cal Poly Pomona student, everybody has access to Excel, Microsoft Word, PowerPoint, all for free. All you have to do is input your Cal Poly Pomona email and your password, and you have all this for free. I just want to remind you. And I'm also going to post this on Blackboard just to help you out too. Okay, so the first thing you want to do is actually create a scatter plot of your data set. So you have to highlight your data set and click on Insert, click on Scatter here. So this is going to make a scatter plot of your data set of whatever you highlighted. So you click on this and you just created a scatter plot. Cool. But notice that it looks very weird. It's because our axis, our y-axis, and our x-axis and our y-axis are weird. So we could actually change this. So what I would do is right-click on this, format axis, and here the minimum is 0, but you don't want your minimum to be 0. You want to be something else. Maybe in your x-axis, let's do 2400. 2400. If you click on this, if you press enter, notice that your chart has changed. But then you also want to change your y-axis here. So you do the same thing. You go to your y-axis, which is right here. Oops. Here we go. And then press there you go. Press format axis. And then here the minimum is 0. But let's make the minimum equals to 380. And if you click on that, then this looks a lot like what we've been working with. Cool. And then we could actually take this a step forward. We could label our x-axis. We could label our y-axis. We can even make a title of our chart here. But for now, I just want to focus on actually computing our correlation coefficient, our R. So here I'm going to put R. We want to find this value using Excel. Well, what we could do is we're going to use a function. So here you're going to press equal. Here you go. This function is called correl for correlation coefficient. So you click on that. So notice that it needs two arrays. The first array is going to be your x values, and the second array is going to be your y values. So here we want to input our x values here, and then you put a comma, and now we want to focus on the y values, which is our selling price of the house. So you give it that, and then you want to close it. So just remember, oops. So let me just, this needs to be all of this. Here we go. Okay, so just a reminder, we're using a function called correl to calculate our correlation coefficient R, and we input our x values and our y values. And now we're going to press enter here. So our correlation coefficient R is going to be equal to 0.9005918. And remember that since it's positive, that means we have a positive association, which what we're seeing here, because it's going upwards. And since if R is getting close to 1, it means it has a perfect positive linear association. It's not equal to 1, but it's pretty close. So that means there is a pretty high positive linear association between size of house and their selling price. So this is how you calculate your correlation coefficient. All right, so let's go back to our notes. Okay, so answering this question, we want to compute the correlation coefficient. So we already did that in Excel. So R here is 0.9005918. And again, this is measuring how correlated these two variables are. Sizes of the houses and its corresponding selling price. So I made a little how-to spreadsheet, or a little instruction on how to create a scatter plot and correlation coefficient R using Excel. So if you kind of forgot, here's like a little step-by-step instruction. So this is for scatter plot, and this is for correlation coefficient R. Okay, so let's do another example. Is here one of the Boston City parks. There has been a problem with mugging in the summer months. A police candidate took a random sample of 10 days out of the 90-day summer and compiled the following data. So for each day, X represents the number of police officers on duty in the park, and Y represents the number of reporting mugging on that day. So here, X represents the amount of officers at the park at that day, and Y is just the number of muggings that happened on that day too. So the first step is we want to construct a scatter plot of our data set. So here, let's say this is 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and then our Y is also 2, 4, 6, 8, and 10. Okay, so here we just plot each corresponding pairs. So here it will be 10 and 5. So you go to 10 and 5, which is right here. And then you kind of do the rest. You plot the rest of the points. And just because of time, I kind of filled out all the points already here. So again, all these points just means the corresponding pair of our data set. So for example, here 15.2 will be 15.2 right here, this dot. So they're just points. So here, from the scatter plot, do you think the computed value of R will be positive, negative, or 0? Explain. Well, if you remember that R is our correlation coefficient, it kind of tells you how correlated two variables are. So notice that this is kind of going downwards. So we know that this is going to be a negative an association. Another way you can think about it is that we have high X values and low Y values. Okay, so here would be we think the computed value R will be negative because there appears to be a negative linear relationship. Cool, because if you look at the plot here, it kind of does. There's like, because it's going downwards, there's a negative linear association. So we want to know, we want to calculate R here. So for that, we're going to need to use Excel. So here I open up another Excel sheet, and I notice that I already inputted our data set here. So here the X values will be the number of police officers at that park, and Y will be the number of reported muggings at that day at that park. So the first thing I will actually do is we'll recreate our scatter plot. So again, you press insert, you press here, and notice that you have something called scatter. You click on this, and notice that this is exactly what we wrote down in our notes. Cool. Now we actually want to compute our correlation coefficient R. So let's write it here. So if you remember, this is going to be equal to, we have to use this function called correl. And again, it inputs two arrays. The first array being the x values, all of this. Then you put a comma. And the array 2 will be all of the y values, which is this. And then we have to close it. Now we press enter. We get our correlation coefficient, which is negative 0.9690786. And notice that it's negative, and because this is going downwards, it's measuring how correlated these two variables are. Since it has like a negative linear association, and it is pretty linear, so that's why we have a pretty, like our R value is pretty close to -1. All right, so let's go back to our notes. Okay, so here R again is equal to negative 0.969, and again I got that from the value in Excel. Okay, so here, what does this value of R tells you about the relationship between the number of police officer and the number of mugging in the park? Since this is pretty close to -1, we could say that there is a strong negative relationship between the number of police officer and the number of muggings. Oops. So it seems that the more officers there are in the park, the fewer the number of muggings. Cool. But we cannot say that more officers causes less muggings. So I'll put that in red. We cannot say that more officers causes less muggings, because if you recall, in our notes here, correlation does not imply causation. If two variables are correlated, this does not imply that one variable caused the other. So that goes the same with this example. Great.